శ్రీ ముత్తవరపు వెంకటేశ్వరరావు కాలేజ్ ఆఫ్ ఇంజనీరింగ్ అండ్ టెక్నాలజీ 2008 లో స్థాపించిన కళాశాలలో ఎంబీఏ, నాక్ ఏ గ్రేడ్ మరియు ఐఎస్ఓ సర్టిఫికేషన్ సాధించిన మొట్టమొదటి కళాశాల శ్రీ ముత్తవరపు వెంకటేశ్వరరావు కాలేజ్.
Today we are discussing about some radiation patterns, that is antenna parameters. Some of the parameters, that is the radiation parameters, are antenna parameters. So let us look at okay guys, please listen. It is a field radiation pattern. Let us look at into this one. Actually, the complete field radiation pattern is a three-dimensional pattern, but we are not able to represent three-dimensional patterns in a plain paper, so that we are going to represent in 2D. It requires three-dimensional representation to represent the radiation for all angles of phi and theta. Phi and theta. We need to require a three-dimensional pattern, as the three-dimensional pattern cannot be plotted in a plain paper. So three-dimensional representation is avoided here. We are going to plot a polar plots, that is E plane and H plane in two-dimensional dimension. These polar plots are plotted in two planes, namely one containing the antenna and the other normal to it, and that is versus. Okay, so these planes, that is E plane and H plane, are called principal planes. Principal planes, and the two plots or patterns are called two principal plane patterns. Again, I am not writing here. If it is about, definitely I will write all those things. Okay, all of you please. This is a paint one, so I am explaining like, okay. What does again, E plane and H plane are also called principal plane patterns. When the magnitude, the normalized field strength, is plotted versus theta with constant pi, theta versus a constant phi, is called E plane pattern or vertical pattern. So let us look at this diagram. This is an E plane pattern. Actually, all of you please assume it is a three-dimensional pattern, but we are representing a two-dimensional pattern, x-axis, y-axis. So into the laptop here z-axis. Okay, x, y is here, but that is not visible, x, y, z. So here uh, the E-plane pattern, how can you represent an E-plane pattern is, the magnitude of E-plane pattern are theta here theta with a constant phi, that is here theta is varying, phi is constant. So this is called an E plane pattern. So what about H plane? That is x and y axis. Here we discarded y axis, so the here y axis came into the picture. Okay, this is a circle, all of you please. X axis, y axis, and it is a phi. Okay, this is H plane pattern, this is E plane pattern. This is H plane, this is E plane. All of you please remember why this E plane and why this H plane. Why it is electric field and why it is magnetic field. Already yesterday's class, previous class, I told you, whenever a source is excited like this, suppose this is a source, okay, this is a basic diagram of antenna. Whenever this source is excited, so as per right hand thumb rule, there is a production of magnetic field and electric field. Okay, so for generation of magnetic field and electric field, we are representing two plane patterns, electric plane, E plane pattern and H plane pattern. So this is E plane pattern is called vertical pattern, H plane pattern is called horizontal pattern. Okay, right now we are I want to draw some other pictures right now. Antenna patterns, antenna radiation patterns. Suppose, all of you please, this is the main source. All of you please assume this is a main source that is generating. Then the radiation pattern is like this. We draw a three-dimensional pattern in a two-dimensional one like this. This is what we call major lobe. Major lobe. These things is what we call minor lobes or side lobes. These things is what we call minor lobes, and this is what we call back lobe. Okay, now suppose this point is the origin point. My major lobe what major lobe indicates means, major lobe indicates just a minute. Major lobe indicates the radiation lobe containing the maximum. So that means the antenna containing the maximum radiation in this direction, that is main lobe. Side lobes and minor lobes are less radiation when compared to major lobes. So this is a back lobe. So actually this is a practical antenna. This is a practical antenna. But what about an isotropic antenna? Already in last class I told you isotropic Tropic antenna or ideal and isotropic antenna. Isotropic antenna means it radiates uniformly in all directions, so that there you can't find these kind of lobes. In three-dimensional view, it radiates uniformly all directions. Isotropic antenna. So in practical antenna, its direction is some somewhere only. That is, if it is a maximum in one direction, a minimum in some other directions. But an isotropic radiator, already yesterday we derived some equation also. Isotropic radiator. So what is the isotropic radiator means? Uh, which radiates energy in all directions, but in a practical antenna it's not possible. So this is the original radiation patterns. We can represent it's a major lobe, minor lobe, that is a side lobes, minor lobes, back lobes. So depends upon the lobe characteristics. So we are observing that. So this is the main lobe. So that its radiation is maximum in this direction only. So it is a minor. It is a side lobe. The radiation is less here. The point between the major lobe and a side lobe, this point is what we call a null. What we call a null. So I will clearly show one picture. Okay, all of you please look at this one. So, types of antenna parameters. Isotropic pattern. An isotropic pattern or radiator, it is defined as hypothetical lossless antenna having equal radiation in all directions. But a directional pattern, it is defined as having the property of radiating or receiving electromagnetic waves more effectively in some directions only. So this is an isotropic radiator which radiates energy in all directions. This is the radar, that is one type of antenna. It's a directional antenna, so that its radiation propagation like this, like this arrow. Hmm? So E plane and H plane. This is an E plane. It is a three-dimensional view, 3D pattern. So in three-dimensional, it is like this. Already I have drawn this one, E plane and H plane. So here radiation pattern lobes. A radiation lobe is a portion of the radiation pattern bounded by regions of relatively weak radiation intensity. Of course, you discuss these things. You please listen my words. So listen. This is the main lobe, that is a major lobe, and these things are side lobes, back lobe, minor lobes, right? These, the polar plot, all of you please listen. Whatever the picture I am showing here is converted into rectangular plot here. Okay, I will draw with reference to this one. Okay, it's very important to draw practically radiation pattern lobes, so that I am writing this one. Of course it may take time. Okay, so you please. Ah, all of you listen. This is a main lobe. Okay, this one is a main lobe. For that one I am writing like this. This main lobe this is the base. Okay, this V type of green sections are what we call center. That center point we assume as 0 within equal intervals, pi by 2 minus pi by 2, okay, minus pi and pi and so on. Okay, so how a major lobe can be drawn? First one, this is a major lobe, so that this major lobe can be written as an equal interval. Okay, rest of the things, what is a side lobe? This side lobe can be written like this, and this side lobe can be written like this. Okay, so by drawing this type of from polar plot to rectangular plot, this is what we call a rectangular plot, we have defined some other parameters of the antenna. Okay, so like this, these are the minor lobes and this is the major lobe. Okay, then the difference between this point and this point, again, what we call this point, already I spoke just few minutes away, the point between two lobes, whatever the lobe it is, maybe it is a minor lobe and side lobe, maybe it is a major lobe and side lobe, the point between two lobes is called what we call this null. What is that one? Null. So the difference between first two nulls, that is, this is a null and this one is a null, so this is what we call first FNW, this one, first null beam width. The difference between these points, that is, this is from off power beam width, what we call off power beam width. Suppose this major lobe, okay, this major lobe, we observe this major lobe, okay, the direction is maximum here, that is, its radiation energy is maximum, the radiation energy is off here. Okay, so the radiation energy off at these points, so the difference between these points is what we call half power beam width, half power beam width. So the half power beam width is one what we call antenna parameter, half power beam width. The radiation the difference between the first nulls is called first null beam width, FNBW, this one. So here half power beam width. So from this diagram only we have written this rectangular plot. This is what we call a rectangular plot, and this is what we call a polar plot. I think all of you please follow some textbooks or internet materials or some other thing, whatever which may useful to you. Okay, the antenna and wave propagation is a little bit interesting as well as the same, a little bit difficult, not a difficult one, it's very easy. Okay, it's a general scenario, it's a polar plot, it is a rectangular plot, right? So the difference between off power radiations, off power energy patterns is called off power beam width. The difference between the first two nulls is called first null beam width. So it's a radiation and it's a x-axis. This is what we call a rectangular plot. This is called a polar plot. Now look at into some other parameters. So it's a minor lobes, side lobes, back lobes. Okay, it's a field regions. Field regions means, suppose if you assume one antenna center of the sphere, center of the circle here. Okay, so this one, the first circle represents a near region, near field region, and the second circle represent a far region, field regions. So suppose here is the antenna. Antenna is excited, energy is radiating. Its radiation energy is maximum, depends upon the strength of our input. Is it right? So near field region, at near field region we may experience more energy while propagating, and some other regions. Suppose if we find out the energy here when compared to this one, so definitely it is a weaker session. So at the near region and far region, so in near region there is a more energy, far region less energy when compared to near region. Beam width, already just now I have discussed this one. Antenna beam width is a measure of antenna. Okay, all of you please look at this one. Already I have told this one. So beam width, generally beam width is called, suppose generally if you spoke a beam width, definitely it is an off power beam width. Beam width between off power point, because the power at that point is just off. So off power beam width is also known as 3 dB beam width. So generally if you if we talk about a beam width, it is an off power beam width. Okay, already we have discussed this one. This is a three-dimensional lobe patterns. This one, three-dimensional radiation pattern. Already in previous our in our sessions, I have written, I have drawn some lobe, just a two-dimensional one. It's a major lobe, side lobe, and some other thing, but it is a three-dimensional pattern. Okay, beam area or solid beam angle. We are getting so many equations here. I will arrange one Zoom meeting. How you people are follow my what we call these kind of equations. If you are familiar with electromagnetic waves and transmission lines, no problem. I will continuously dictating these kind of equations. But the thing is, you people you have to understood. So let us look at into this one, beam area or a solid beam angle. So what is a beam area? Beam area means, already this is an off power beam width, this is a main lobe, the area, suppose this this main lobe, this is the main lobe. Here the dotted lines are my expectation, but this is the practical antenna that radiates its energy. So this dotted line is my expectation. That is, suppose if you assume this is an ideal isotropic antenna's radiation, this is a practical one. We have to compare this practical with the isotropic antenna. అంటే ఐసోట్రోపిక్ యాంటెనా ఎంతవరకు రేడియేట్ అవుతుందో చూసుకుని దాన్ని కంపారిటివ్గా స్టేట్మెంట్స్ అనేవి ఇక్కడ తీసుకుంటాం మనం. సో సో అలా తీసుకుంటే కనుక ఏ యాంటీనా పవర్స్ని అంటే ఏరియాని ఏ విధంగా క్యాలిక్యులేట్ చేస్తాం, బీమ్ ఏరియా ఆర్ సాలిడ్ బీమ్ యాంగిల్. సో కన్సిడర్ 2-dimensional పోలార్ కోఆర్డినేట్స్. సో ఇప్పుడే మనం జస్ట్ we talk about polar coordinates, E plane and H plane. Okay, so the area on the surface of the sphere is the product of the length r d theta in theta direction and r sin theta d phi in phi direction. This one, these 2 points you must know. Okay, area, if you want to find out the area dA, it is the product of the sphere, this one, the length of the product of the length r d theta in theta direction and r sin theta d phi, r sin theta d phi in phi direction. So where d omega is what we call a solid angle expressed in steradians, d omega, so dA equal to r d theta into r sin theta d phi, r square d omega. D omega means solid angle expressed in steradians. What is a steradian and a radian? You know what is a steradian and what is a radian? You know about, I think you people know about radians, and here the new word is steradian. I will explain these things also, radian and steradian. Okay, okay students, today we just talked about a rectangular plane pattern, and what about a lobes, a major lobe, side lobes, back lobe, and minor lobes, and what is a null, and what is an off power beam width, and what is an first null beam width. Okay, this is about a lobe section. This is a polar plot, and this one is a rectangular plot. Okay, and E plane and H plane already I have drawn in paint, E plane and H plane. E plane pattern is also called a vertical pattern, this one is also called a horizontal pattern. E plane is associated with theta with a constant phi, and this is with phi. H plane is with phi. So these are the plane patterns. E plane and H plane is called plane patterns. From the first point, we have you people please observe what is an antenna definition. Okay, and what are the types of antenna. Up to now we have discussed what is an antenna. Antenna is a transducer, which our antenna is what we call a radiating source. Different types of antenna we have speak out. Okay, antenna, and next one is an antenna parameters. Okay, so what type of parameters is so on, and what is some isotropic radiator. Last class, this is an isotropic radiator. So isotropic radiator and radiation mechanism, how the waves are detached from an antenna, radiation mechanism. Okay, again antenna definition, different types of antennas, a radiation mechanism, an isotropic antenna, and E plane and H plane. Okay, E plane and H plane, and a polar plot and a rectangular plot. Okay, coming sessions So here one by one so many new kind of parameters, new kind of things we are going to learn. So every time you please follow some materials or textbooks which available in the internet, or I will provide some materials to you. So please follow up these things. Again, if you have any doubts, you feel free to contact me. Thank you very much.